Welcome back. So in the last video we talked about the concept of resultant forces. Now what happens, I talked to you what happens when an inclined force is given to an object. When an inclined force has some component in some direction, so what happens when an inclined force is given to that object, and then we can easily find what happens to the system. Alright, so I told you that I will talk about a new theory called a parallel triangle law in this video. So before introducing the concept of triangle law, I have to introduce some more definitions about the triangle law. So I will take some two forces. Now this is actually a definition of the triangle law. So define triangle law, I am using one example. Alright, so what if I have some force F1 in this direction, right? F1 in this direction, which is horizontal, and another force F2 which is inclined 120 degrees. 120 degrees F2. So what you will do, so this is, I'll take a 60, not 100, right? 60. So this is actually, I was meaning this angle, this is 120, this is 60, right? This is 120, this is 60, alright. So what happens now, what you will do from the example you learned from the last video, what you will do is that you will decompose this into the horizontal component and the vertical component, and then find the total horizontal or the net horizontal force, net vertical force, and then find the resultant of the forces. So without going through such a hassle, there is an easy way to do that. So that's called the triangle law. So I will take, now if I take a force like this, if I take some force like this, this is called the head of this force, head, and this is called the tail of this force. Alright, so this is called the head, this is called the tail. So the triangle law says, or sometimes called the triangle theorem as well. So the triangle law says, if you take in these two vectors, if you place the tail of the second vector on the head of the first vector, tail of the second vector on the head of the first vector, then the resultant of these two forces will be given by an arrow in which the arrow of the resultant forces, the tail of the resultant forces will coincide with the tail of the first force, and the head of the resultant force will coincide with the head of the second force. Now this is like this. Now first of all, you have to place the tail of the second force, this is the tail of the second force on the head of the second force. Now these two points, this point and this point will coincide. Now I'll take this and I'll translate it to here. So these 2 points will coincide. So what happens is like this. So F1 here and F2 here. So this is what I'm talking about. Tail of the second vector on the head of the first vector. This is the head, this is the tail. Tail of the second vector on the head of the first vector. So the resultant of these two forces will be an arrow in which the tail of the resultant force will coincide with the tail of the first force, and the head of the resultant force will coincide with the head of the second force. So there is only one way you can distribute like that. So if I take an arrow, it should be like this. This is FR, right? FR. So now we can put the triangle law. Tail of the second vector placed on the head of the first vector, and the resultant force will be so that the tail of the resultant force will coincide with the tail of the first vector F1, and the head of the resultant force will coincide with the head of the second force, which is F2. So this is triangular law. So we don't usually, this is correct, this is 100% correct, but we don't usually draw like this. What you do is you take some force like this, you take this one as F2, F1, this is F2, and the resultant will be like this. Right? This is simply triangle law. Alright, now for this problem, how can we apply the triangle? Now, before, now this angle is 60 actually, and this is 120, right? This is 60 and this is 120. So we can only apply triangle law in a position in which the tail of the second vector is placed on the head of the first vector. Now, if the tail of the second vector is placed on the head of the the tail of the second vector is placed on the tail of the first vector. Now we have somehow, it is by drawing either a parallel line or some other construction in which we have to develop like this. If we have the tail of the second vector on the tail of the first vector, we have to draw some parallel line or some other construction in which we draw this accordingly in order to put the triangle law. Alright, so that's the basic necessary for the triangle law. So if I take some forces like this, if I take force of 2 newtons and a force of 6 newtons, so this will be Fr, and this angle I will take as 60 degrees, right? This angle is 60 degrees, now we have to find Fr. So what you can actually do is, this angle is 120, right? This angle is 120. You can easily put the cos theorem. Alright, so cos 120 is equal to, cos 120 is equal to 2 square plus 6 square minus Fr square divided by 2 times 6. Right? So cos 120 is minus cos 60 is minus half, so that 2 will cancel to one of these 2's, so there will be minus, so minus times 2 times 6 is minus 12, it will go here, this is minus 12, 2 squared is 4, 6 squared is 36, so 4 plus 36 is 40 here, minus Fr square. So Fr square will be equal to 40 plus 12, 52, so Fr is equal to 2 root 30 newtons, right? 2 root 30 newtons. So that's simple, right? If you don't know what is meant by the cos law, what you can do is, you can draw this triangle in another way, right? So this angle is 120, you can draw this like this. What you can do here is that right, you can draw a triangle like this. So this is 60, so this is 2, this is 6. You can draw a perpendicular like this and then find, so this is 6 cos 60, this is 6 sin 60, so you can multiply, add these forces like this. Now you will say this is the same thing, right? Now in this example, now if you are putting cos theory, it's okay. If you are taking this one, so this is 6 sin 60, sorry 6 cos 60 and this is 6 sin 60, and then you add up 2 plus 6 cos 60, that is 6 times half is 3, so this is 5, 6 sin 60 is 3 root 3, so you take the square of 5 squared plus 3 root 3 squared, so 3 root 3 squared is 27, 5 squared is 25, so 25 plus 27 is 52, so Fr will be equal to root 52, so that will be the same answer. But you will say that's the same thing. Now you are saying that's the same thing because there are only 2 forces here. What if you have about 8 forces, and 8 forces in which 2 forces are vertical, 2 forces are horizontal, and the other forces, all the other forces are horizontal, all the other forces are inclined, so it has some inclination to either to horizontal or to the vertical. So what if have some objects like this? So it will be a complete hassle. So the best thing you have to do is, you can construct a simple triangle in which you know many theories. You can either draw a perpendicular and then put the Pythagoras theorem. If you are well versed with trigonometry, you can put the sine theorem or the cos theorem, and if you are very advanced use of trigonometry, you can even put the cot theorem. So that's a simple use of this triangular law. So what I mean by this video is that to introduce what is meant by triangle law. So for any problem, so you know how to draw and you can construct the triangle here when you are given some forces. So what is actually important is not the solution of this problem. What is actually important is how to construct. So if you have some force in this, 2 forces like this, 2 forces that are inclined, you have to place the tail of the second vector on the head of the first vector, so the resultant of these forces will be so that the tail of the resultant force will coincide with the tail of the first force, and the head of the resultant force will coincide with the head of the second force. So that's triangle law. So if the forces are not arranged in such a manner, you can do some construction and arrange in that manner, and then you can put triangle law. So that's the importance of triangle law. So in the next video, I'll introduce another concept, which is the parallelogram law. So parallelogram law is actually a derivation of triangle law, and vice versa as well. So you can say the triangle law is also a derivation of parallelogram law. So there's a simple relationship between these two laws. So in the next video, I'll be talking about the parallelogram law. So thanks for watching this video, and see you then.